So, good afternoon, students. Now, in our previous lectures, we have been completed with most of the tests which constitute your large sample test, in which we have studied Z test. Then we have also studied the small sample tests, in which we have studied your T test and then chi-square and F test. Out of these four tests, Z test and T test was particularly applied for hypothesis testing about the mean, and that of chi-square and F test was used for hypothesis testing about the variance. So up till now, what we were doing was that from a sample, or we were comparing two populations from one from the other. Now today we are going to deal with another very important topic, and this topic is analysis of variance. And I can say that this is one of the greatest discovery in the mankind, which has enabled lot of researchers to carry out their research and find out the assignable causes to the outcome. So we will be studying this, and if there is a question in statistics, it is ought to come from the ANOVA. And what you can say is that this ANOVA, analysis of variance, is the summary of what you have understood up till now. Okay, and it has a vast application in statistics. So let us start today's lecture and find out that what is analysis of variance. Okay, so starting with the introduction, the analysis of variance focuses on variability. Okay, we know that in our nature, you take any of the trait, let it be height, weight, you took anything. There is one of the important thing there is variability. That is, nothing is same from one person to other. Okay, there is some differences are always there. Okay, in most of the traits. So this analysis of variance, it involves the calculation of several measures of variability. So when we will be doing this analysis of variance, we will be calculating several measures of variability, all of which come down to one or another version of the measure of variability, such as sum of square deviations. So that is what we will be studying in this ANOVA, is sum of square deviation or mean sum of square deviation. So finally, this variation we are going to make a gist or summarized table in which we will be calculating the mean sum of square deviations. Okay. So the statistical technique known as analysis of variance, commonly referred to as acronym ANOVA. Okay. In short, it is generally being called as ANOVA, was developed by Professor R.A. Fisher. So ANOVA was discovered by Professor R.A. Fisher in 1920s. So in 1920s, it was R.A. Fisher who has discovered this analysis of variance technique, by which you can analyze the variation available in data. Okay. So as I have already told you, that variation is inherent in nature. You take anything, okay, there is some variation from one thing to other. Even you measure something with the same instrument, some sort of variation is ought to come there. So analysis of variance means examining the variation present in data or parts of data. Okay. So what we will be doing? We will be analyzing the variance, okay, that is present in our data. In other words, analysis of variance means find out the cause of variation. Up till now, we were simply comparing the variation in F test also, in chi-square test also. What you are doing is that the variance of this sample is greater than or equal to this variance. Okay, but now Using this analysis of variance technique, which was discovered by Professor R.A. Fisher, you will be able to find out the significant or assignable causes of variance in the data. Okay, variation in the data. So, the total variation in any set of numerical data, let it be any data, any numerical data of an experiment, is due to number of causes. Okay, say for example, you say the milk yield. Okay, so milk yield is due to the what nutrition you are feeding, in which lactation your buffalo is. Okay, lactation stage, that is whether it is in the initial stage, mid stage, or the late lactation stage. Then which parity it is, that is it is a heifer or a buffalo in third or fourth parity, or it is in the late parity. Okay, then it will depend on the how much genetic this constitution it has inherited from its mother and father. Okay, so it will depend on a number of causes. Okay, which may be assignable causes, which you can assign, as I have told you some of the causes. Okay, so you can assign them, and others will be unassignable or chance causes. Okay, those you cannot identify that why this variation is there. Okay, so the variation in data due to assignable causes can be detected. Okay, if it is a assignable, it can be detected. Okay, it can be measured. Okay, and it can be controlled. Fine. Whereas the variation due to chance, so what I have told you, that if it is a assignable cause, it can be detected, measured, or controlled. But if it is due to chance, if your this variation is due to chance, it cannot be controlled by the human beings and cannot be traced, or neither it can be calculated, neither it can be measured. Okay, so it is only the assignable causes which can be controlled, detected, and measured. Okay, the reason this analysis is called analysis of variance. So what we are actually going to do here is that we will be comparing multi-group means. Okay, that is, in this analysis of variance, we will be having more than two populations. So we will be comparing multi-group means, but it is not known as multi-group means. Rather, it is called as analysis of variance. Why? Because it compare group means by analyzing comparison of variance estimates. Okay, that is how it is going to compare your group means, by analyzing comparisons of variance estimates, and that is why it is called as analysis of variance. So analysis of variance facilitates the analysis and interpretation of data from field trials. So we conduct so many field trials, from that you can carry out this analysis of variance. You can carry out this thing in laboratory experiments in agriculture and biological research. Okay, so today it constitutes as one of the principal research tools. It is one of the principal research tool. I can say if there are 1,000 research theses in library, so at least 990 will be having this ANOVA in them. Okay, so it has become one of the principal research tool of the biological scientists, and its use is spreading rapidly into the social science, in physical sciences, and in engineering, in management, everywhere. Okay, so up till now, previously in previous lecture, we have compared means from two independent groups using the t-test. But what if we are interested to test more than two independent groups? Okay, so if we are interested to test more than two independent groups, then t-test cannot be applied. And firstly, we have to apply the analysis of variance technique. Then we can apply your, okay, because here there are more than two independent groups. That is why we are going to apply the analysis of variance. If it could have been two groups, then F test are used. Okay, so here In this analysis of variance technique, this F-test is used to test the means of several groups. Okay, so it analyze the data in such a way that your F-test can be used to test the means of several group in one group. Okay, so this F-test was named F in the honor of Professor R.A. Fisher by G.W. Snedecor, and particularly this the multiple two sample t-test. If we do not do this f-test or this ANOVA, instead we do multiple two sample t-test, it would result in an increase of chance of committing a type 1 error. Okay, so if we will be analyzing your groups using the t-test instead of your ANOVA, then what you will be going to do, there are increased chances of committing type 1 error. Okay, so we cannot because let it be many groups, we can apply in 2 we can apply the t-test, but in that case we will be committing a type 1. So that is why we should go ahead with the analysis of variance technique. So, the test of significance based on t distribution is an adequate procedure only for testing the significance of the difference between two populations. Okay. So, in a situation when we have more than two populations to consider, okay, then we will be having more than two populations to consider at a time and want to test the mean of these population at the same time. Okay. So, for example, say for example, you have 5 doses of drug applied to 4 patients. Okay, you have 5 doses of drugs, right? And each drug is applied to 4 patients. So you will be in total having 20 patients, isn't it? There will be 20 patients will be there. Now we may be interested in finding out whether the effect of 5 doses of drug on the patients significantly differ. Now there will be, how many groups will be there? There will be 5 groups. Each group has been given a separate dose. And we want to find out that which dose is having a significant higher or lower effect than the other. So in such cases when there are more than 2 groups, okay, then we go with the analysis of variance technique. So the answer to this problem is provided by the technique of analysis of variance. Thus, the analysis of variance technique is used to test the homogeneity of several population means. Okay. So now we will be just go through some of the types of variance, right? So according to Professor R.A. Fisher, analysis of variance ANOVA is the separation of variance ascribable to one group of causes from the variance ascribable to another group. That is, what, say for example, we have group A, we have group B. Okay. So by this analysis of variance technique, okay, what you can do, you can ascribe that how much of variance is due to this A and how much of variance is due to B out of the total variance, right? So by this you can find out, what you can do is, so by this technique the total variation present in data are divided into two components. Okay, what we are going to do is, we are going to uh, mm, find out the variation present in the data into two components. One will be due to assignable causes, and that is called as between group variability. That is how much one group is variable from other group, and other variation will be within the same group. That is, within this group there will be number of observations, so within group variability is also there, so that will be due to chance, and between group we can find out. Okay, so other variation is due to chance, and this chance variation is known as within group variability, right? So the variability due to assignable causes is between group, and that of the chance causes is within group variability, right? Now, the analysis of variance technique solves the problem of estimating and testing to determine whether to infer the existence of true difference among treatment means, among variety of means, and other certain condition among other means with respect to the problem of estimation, right? So by this technique we can tell that this group, say for example there are 2, 3, 4, 5, 6 groups are there, and we can tell by applying this analysis of variance technique that variation between these groups, okay, is this, okay. So analysis of variance technique can be classified as follows, that is it can be a parametric ANOVA and it can be a non-parametric, okay. So parametric ANOVA can classified as simply ANOVA, we do not add anything, okay. So if only one response variable is considered, okay, if there is only one response variable is considered, and if more than one response variable are considered, then it is called as multivariate analysis of variance. So we are not going to deal with the multivariate analysis of variance. So only, say for example, one character we will be finding, say for example height or yield, milk yield or weight, okay. We will not be concerned with height and weight simultaneously, okay. That is height and weight is affected by this particularly age of the person or some other factors. So we will be considering only one response variable, that is either height or weight. If we are going to take more than one response variable, then it is known as MANOVA, that is multivariate analysis of variance. If we consider only one independent variable which affects the response, say, see, actually there are response, as I have told you, that milk yield. So milk yield can be ascribed as a response. Now this can be due to the milk yield, the variation in the milk yield, right? This variation in milk yield can be due to assignable and chance factors. So these assignable factors, okay, which can be, say for example, parity, body weight, right, lactation stage, breed, right, and these chances we cannot ascribe that why this variation is there in the milk yield, right. So these can be, so this is your response which is called as dependent variable, and your assignable factors are nothing but the cause, and these are independent, right. So this dependent variable is dependent on the independent variable, and generally these dependent variable are continuous, that is they are scale, like height, weight, milk yield, like this, right. Whereas these independent variable like parity, okay, or lactation stage or breed or body weight category, okay, so they are nominal in nature, these are nominal. So by these independent variable, we are going to group the data. That is, if we have a milk yield data, we will group it according to parity or say for example breed or say for example lactation stage, and then we will find that how much of variance is due to breed or lactation stage or parity, right? That is the variation in the milk yield that is due to the breed, or variation in the milk yield that is due to parity. or variation in the milk yield due to the body weight. So when we will be taking only one character, it will be simple ANOVA, and when we will be taking more than one response variables, then it will be MANOVA, right? So this is what we are studying, right? So if we consider only one independent variable, that is out of this parity, body weight, lactation stage, if I will be taking only, say for example, lactation stage, then it will be one way. If I will be taking two, then it will be two-way ANOVA. And if I will be taking, say for example, n numbers of assignable causes, then it will be n-way ANOVA. So in this particular lecture, we will only be studying about the up to one-way ANOVA and two-way. Rest we will not be studying because that is beyond the scope of your syllabus, right? So another ANOVA is factorial ANOVA, which is used when the experimenter wants to study the interaction effects, right? If you want to find out the interaction effects, then we go for this factorial ANOVA among the explanatory variables. So these causes, these assignable causes, these are also known as explanatory variables. Three variables, explanatory variables. So another is your this is factorial ANOVA, which I was discussing, right? Then another is your repeated measure ANOVA. Okay, what is a repeated measure ANOVA? It is used when the same subject experimental units are used for each treatment level of explanatory variable. Okay, that is repeated observations are observed. Then MANOVA we have already described. Now the F test in ANOVA has been used with normality assumption. Okay, but there are some cases when the distribution of the response variable and its transformation is not normal. Okay, in such cases, the variable, say for example, your response variable Yij is actually not normal, and the appropriate information which will make it normal is unknown. So we need known parametric ANOVA methods. And there are some of the known parametric ANOVA method which is known as Kruskal Wallis one-way ANOVA by ranks. This is a known parametric type of ANOVA. And one-way repeated measures of ANOVA for non-parametric variable is Friedman test. Okay. So these are some of the known parametric ANOVA which are used. So this technique can be used in different statistical linear models like in fixed effect, random effect and mixed effect. So we will not be going into details of fixed effect model, random effect model or mixed model. Here we will only be discussing about the fixed effect model. Okay, when there is no interaction among the your explanatory variables. Okay, that is the explanatory variables are independent of each other. That is known as fixed effect model, right? And if your explanatory variable are itself random, you know random variable that also depends upon chance, then it becomes a random effect model. And if your ANOVA is having both fixed variables and your random variables, then it is known as mixed type of ANOVA, right? So this is how it is described. So we will not be taking up this random effect model or mixed effect model. We will only be discussing here the fixed effect model. Okay, now there are certain terms which need to be taken up before going for your this ANOVA, right? So we will be discussing them one by one, because when we will be discussing the examples of ANOVA, so there will be certain terms will come, and most of many of the terms has already you have already gone through, but these terms has again been described in reference to ANOVA. Okay, so once you have familiarized yourself with the terminology of analysis of variance, now you will find it easier to grasp many of the parametric techniques that you read about in this lecture. Okay, so some of the terms described below may be referred uh, to by one of many names as indicated below. Okay, so one is variable. What is a variable? A characteristic or attribute varies in a measurable way between subjects in the set. Okay, so any characteristic or attribute that varies in a measurable way, and it should be measurable, right, between subjects in a sample is known as variable, right? Now, what is the response or dependent variable? As we have already described, this is response variable milk yield. So, it describes the measurement usually on a continuous scale, as I have told you, of the variable of interest. Say, for example, weight. What causes the variation in weight? Then comes your explanatory or independent or predictor or treatment or factors. So these are different names of these assignable causes. That is explanatory variable, independent variable, predictor variable, treatment or factor. So effect X, explanatory variable is controlled by the experimenter. It is controlled by the experimenter, right? Which may affect the response. Response does not affect explanatory variable. It is not the milk yield does not affect the parity. Parity is fixed. Okay. So response does not affect the explanatory variable. The non-random measurement of observation. Say for example, treatment fixed by experimental design, which are hypothesized in a statistical model to have predictive power over the response variable. So this hypothesis is tested by calculating sum of squares and looking for a variation in y between levels of. So what you will be looking for? What is the variation in y? That is response variable between the levels of x. Okay, between the levels of x that exceeds the variation within levels, and this between variation should exceed the variation within levels. Then only we can say that this grouping or the levels of x significantly affect the variation in the y. Okay. So an explanatory variable can be categorical. Say for example, sex with two levels like male and female, or continuous height with a continuum possibility, right? So the explanatory variable is assumed to be independent in this sense of being independent of the response variable. Say for example, weight can vary with height, but height is independent of weight. Okay. So the value of x are assumed to be measured precisely without error, permitting an accurate estimator of their influence on y. So explanatory variable may be fixed, random or mixed as per your statistical model. But in this case particular, this lecture, we will be taking up only the fixed explanatory variable, not the random, neither the mixed type. Okay. So now comes your variates, replicates, observations, scores, data points. What are these? So the replicate observation of the response variable, that is you will be having responses. So say for example milk yield. So different buffaloes will be having different milk yield. Say for example you have three groups. You have categorized the LRC buffaloes on the basis of parity. First parity animals, third parity animals, fifth parity animals. So in first parity, there will be certain responses will be there, right? So how much this particular buffalo gives milk. So there are replication and observation. That is in first parity, there are 10 buffaloes are there. So those 10 constitutes your replicate observations of the response variable, and they are measured at each level of explanatory variable. That is in first parity also you will calculate that how much these 10 buffaloes will produce. Then for third parity you will see that how much other 8 buffalo or 10 buffalo or 12 buffalo will produce. Okay. Then at fifth parity animal how much they are producing. Okay. So each level of explanatory variable you have replicates of observations, right? So these are the data points each usually obtained from a different subject to ensure that the sample size reflects an independent replicates, and it is not inflated by the non-independent data or pseudo replication, right? So now comes your sample. The collection of observation measured at a level of X. So say for example, body weight were measured from one sample of males and another from the females. So your sex becomes your categorization for sample. That is the sample from males and sample from females. So if X is continuous, the sample comprises all the measurements of Y on X, right? Now, sum of square. The square distance between each data point and the sample mean, summed for all n data points. So the square deviation measure variation in the form of which can be partitioned into different components that sum give the total variation. For example, the component of variation between samples and the component of variation within samples. So between and within, assignable causes and unassignable causes. These can be partitioned, these sum of squares, right? Now variance and standard deviation. The variance is a normally distributed population. Variance in a normally distributed population is described by the average of n square deviation from the mean, right? You have already studied. And variance usually refers to a sample, however, in which case it is calculated as the sum of square divided by n minus 1 rather than n. If you are going to calculate the variance of a sample, then you have to divide the square deviation from the mean by n minus 1 instead of n. Its positive root is then the standard deviation. If you take the positive square root of that variance, it gives you standard deviation, which describes the dispersion of normally distributed variable. So we have already studied the normally distributed variable. Say for example, 95% lying within 1.96 standard deviation of the mean when the n is large. Okay. Now comes your statistical model. What is a statistical model, right? So here it is written that y is equal to fx plus e, where fx is some function of x. So a statistical model is nothing but a hypothesized relationship between the response variable and the predictor variable. You have this response variable, you have the causes, so it gives you an association or a equation between the response variable and the predictor variable, right? So say for example, simple model is like that weight, right? Weight is equal to sex plus error. So E, where this equal to does not signify literally equality, okay, but it is a this equal to. This equal to is not equal actually. So many people confuse that this is equal. How weight can become equal to sex? This is actually the statistical dependency. This is actually the statistical dependency. So the statistical analysis is going to test the hypothesis that the variation in the response variable on the left side of the equal sign, that is weight, is explained or predicted by the factor on the right side, that is sex, in addition to a component of random variation, the error term. As we have already told you that this is your response, these are your assignable causes, these are your unassignable causes, which you cannot find out. Okay, so some of the variance will be calculated from this predictor, but the rest will go into the error, that is which you cannot find out in your model, that because of what this variation is coming in the weight. Okay, so the statistical analysis is going to test the hypothesis that the variation in the response variable on the left of the equal sign weight is explained or predicted by the factor on the right sex, in addition to a component of random variation error. So there will be your response variable, okay, then there will be predictor, and there will be random variation, that is E. Okay, so a analysis of variance will test whether significantly more of the variation in weight falls between the categories of male and female, and so is explained by the independent variable sex that lies within each category of the random variation E. So male will be having some variation within them, female will be having some variation within them, and there is a variation between the males and female group. Okay, so if within variation and the between variation is greater than within variation, then we can say that the male or the sex have a significant effect on the this weight. Okay, so the error term is often dropped from the model description, though it is always present in the model structure. as the random variation against which to calibrate the variation between level of x in testing the significant explanation, the f ratio. So generally it is not written, but it is there. Okay. Now comes your null hypothesis. We have already studied these null hypothesis. Then we have, okay, let us revisit it. While a statistical model can propose a hypothesis that the response variable y depends on independent variable. So here in the context of ANOVA, earlier we were telling whether the sample means were equal or greater than or less than. But here your purpose of hypothesis is that the response variable y depends on independent variable x. Okay, that is our hypothesis. So the statistical analysis can only seek to reject a null hypothesis that y does not vary with x. So this is because it is always easier to find out how different things are than to know how much they are the same. So the statistician easiest objective is to establish the probability of a deviation away from the random expectation rather than towards any particular alternative. So if the analysis reveals a sufficiently small probability that the null hypothesis is true, then we can reject it and state that y evidently depends on x in some way, or the hypothesis of null hypothesis. So we will just take up it when we will be taking the example, so it will be much clearer to you. Okay. Now, one way ANOVA. If we are taking only one assignable cause, then it is known as one way ANOVA. If we are taking more than one assignable causes, say for example x1 or x2, then it is two-way ANOVA, right? Then comes your error or residual. Okay, so what this error which I have described. So the amount by which an observed value of a variable differs from the value predicted by the model is known as error. Say for example, you constructed a model, you find out a equation that y is equal to actually 3.5 times of x plus e. So in population you will be having certain values of x, you will be having value of y. Say for example this is weight, and this is say for example height, right? So when you will be multiplying this, so you will not get the exact observed value of y in the population. Okay, that is, you got a equation from the data of your class. Say for example we take the data of your class, the weight of all the students, the height of all the students, and then find out that it has a relationship of y is equal to 3.5 into x plus e. Okay, so when we will be putting these values, so you will find that it will not be able to find the correct value of your weight. So there will be some error. What is that error? That is e. Okay, and as far as this ANOVA is concerned, if you follow its this your uh, regression equation, that is, if you will find the regression coefficient and then find this equation, then this error will be least, right? So this is your residual, right? So errors or residual are the segments of scores not accounted for by the analysis. So by analysis, it is not able to find out this E. So in analysis of variance, the errors are assumed to be independent of each other. This is very important because it is one of the assumption of this ANOVA. That is, the errors are independent of each other and normally distributed about the sample base. They are also assumed to be identically distributed for each sample, since the analysis is seeking only a significant difference between the sample means. So, which is known as the assumption of homogeneity of variances, right? Now, you know normal distribution. Okay, so it is one of the assumption of ANOVA that the data on which you are applying ANOVA is from a normal distribution, and it follows the symmetrical bell-shaped curve, right? Then what is the degree of freedom? The F ratio in analysis of variance is always presented with two sets of degrees of freedom. The first corresponding to 1 less than the level P of the explanatory variable, and the second to the remaining error degrees of freedom, which is n minus P. So you will be able to understand that how we will be find out these degrees of freedom when we will be doing your analysis of variance table, right? Okay. Then when we will be doing this analysis of variance table, these all terms will come. What is variance ratio? Variance ratio is nothing but the F statistics. So the statistic calculated by analysis of variance, which reveals the significance of hypothesis that response variable depends on the explanatory variable. So it comprises ratio of two mean squares. Okay. So we will be finding the ratio of two mean square. What are these? These are mean sum of square due to explanatory variable divided by the mean sum of square due to error. Okay. So when we will be dividing the mean sum of square due to explanatory variable divided by mean sum of square due to error, it will give you F statistic. Then what is significance? This is the probability of mistakenly rejecting the null hypothesis that it is actually true. Okay, this is another way of explaining the significance, right? Then p-value. In a biological science, a critical value p generally we take at 5% level is generally taken as making an acceptable boundary of significance. A large F ratio signifies a small probability that the null hypothesis is true. Okay. Then what is mean sum of squares? So mean sum of square is the average sum of square. In other words, the sum of square of deviation from the mean x. Okay. Or error E divided by its appropriate degrees of freedom. If you divide the sum of square with the degrees of freedom, you will be getting mean sum of square, right? Now, what is the population? All subjects, experimental units possessed by a common characteristic that is being studied, whereas a group of subjects selected from a target population is known as sample. Okay. So what is population? All subject. If we take all the subjects, then it is population, and if we take some target population, then it is known as sample. Okay. We have already studied this thing. And what is parameter and statistics? Parameter is for population and a statistic is for your sample. So we will be winding up this lecture here itself. So now we have studied various terms, those we are going to use in analysis of variance technique. Okay. Then we have studied about your response and the predictor variables. Then we have studied about the types of ANOVA in this lecture, and we have gone through the introduction of ANOVA. So tomorrow in this practical, okay, so we will be taking up with the one way and the two way ANOVA. Now one of the student is asking that uh, what type of questions will be asked in your examination. See, as far as the examinations are concerned, uh, your theory exam will be having the conceptual questions. The numericals will not come. Okay. But for your practical exam, generally numerical questions are being asked. Okay. And it will depend that whether your exam will be conducted online or it will be conducted offline. So that depends. If it will be offline, so it will be like what has been described by the VCI, and if it will be online, then it will be what has already been notified by the board of management of the university. Okay, so accordingly that will be we will be doing. And I think this particular we can take up one exam on Saturday from the first chapter, that is introduction of statistics. Okay, for your class, that will be an online exam, and that will be during your class only. So I think I will tell you that will be of half an hour. If there are around 30 questions are there, if say for example, uh, let it be 20 minutes question, 20 minutes of 20 questions. Okay. So we will be having exam on Saturday. from your first chapter, that is introduction of statistics. Okay, so those marks will be added in your practical exam, because 10 marks is with us for your this viva voc and your record maintenance and all these things, and the test will conduct your regularity attendance test. So that will be added up to. So I will be taking a test on Saturday. Okay, so you will get an idea that what type of true false and these objective type questions will be asked in your exam. And I will tell you one thing, that the exam we will be taking for you will be a little bit different. Okay, and every student, if say for example there are 83 students, so that exam will be having 83 sets. That is, every student will get a different set of questions from the question. Okay, that program I have already made. So it you have to study. It is not like that that every student will be getting the same 20 questions, uh, and the only the sequence will be jumbled. If there are 80 students are there, and say for example in my question bank I have 100 questions. Okay, so 20 questions will be randomly allotted to each student from those 100 questions. Okay, and your question paper you will be getting on your email. Fine. And then on that email only you will be getting a link to submit your OMR sheet. That is, the Google form will only be having the your question number and four options. Okay, there is nothing will be written in the Google form. Question will be in your mail. So simply what you have to do, you have to take one paper, write down your answers, that for first it is A, for two it is B, for three it is D, for four it is A, and then you have to tick that thing in your Google form and submit it. That's all, with the passcode of your paper, and that will automatically come with your this email. Okay, that you won't be required to fill up anything. Only you have to fill up the answers to your question in the sequence which has been allotted. Okay, so that we will do on Saturday. So this is all from today for ANOVA, and I think tomorrow I will be able to complete this ANOVA, and on Saturday I will try to take your this exam from first chapter, that is introduction of statistics. Okay, so thank you very much. Thanks for being with me, and if there is no more questions, so I am just closing the lecture.